Hello and welcome to R&D Mathematics. Today we are going to talk about composition of functions. Composition of functions. Now let's take two functions, f of x and g of x. Now we define composition of functions by f circle g. We call it f circle g of x. That is actually f of g of x. So we call this f of g of x. So f of g of x. Now what's happening here is actually there are two machines. Remember I told you function is like a machine. So you first input your input or x into one machine and the output goes through the other machine and comes out as f of g of x. Now at this point I would like you to pause the video and think which order they appear. Okay, actually the first one is g, because when you throw x into g, the machine g, what comes out is g of x and it goes into the machine f, see here, and what comes out is f of g of x. And similarly we can define the other way around. G of f of x is going to be g of f of x. So this time the machine first is f, so x goes through f and comes out f of x, and it goes through g, and what comes out, g of f of x. Now at this point you may wondering about the domains. Yes, as long as range of g is inside the domain of f, in the first case I'm talking about right here, the range of g, so what comes out, as long as it's allowable to go through f, so as long as the range of domain is inside, sorry, range of g is inside f, or range of first function is inside the domain of second function, that's okay. Now even though this is the theory part guys, but when it comes to practical application we have to get a little bit more technical, so you cannot keep doing diagrams. So let's start with some examples as usual. Now let's say we have two functions, f of x squared minus 7, and let's say g of x equal 2x. In this case let's evaluate both of them. Let's first evaluate f circle g of x. By definition, this is, first what you need to write down the definition f of g of x. Now there are two ways of doing it, so I will teach you both ways. So method number 1, method number 2. So method 1, method 2. Now it's up to you to choose whatever the preferred method. Okay, method number 1. So let's keep f and g of x is 2x, so write down 2x. Now f of 2x, now the shape of x is whatever you throw in x, it will square it and minus 7, right? So for example, f of this guy, remember I was talking about this guy in a function introduction video, this guy squared minus 7, right? Now instead of that guy, what if I throw g inside f? What I will get it g squared minus 7. So what's happening here? So 2x squared minus 7, it is 4x squared minus 7 is the answer. Now method number 2, what I am doing is, first I am using f. So in method number 1, I wrote f and wrote g, I substitute for g of x the given value, and now here what I am doing, looking at f, I know f will square minus 7 whatever you throw, so it will do the same for g, right? and gx, you know, 2x squared minus 7, so it's getting 4x squared minus. Ultimately, they are, the idea is the same, just a simple difference between the first step, right? So as long as you get the clear idea, it doesn't matter which way you do that. Now, how about the other way around? How about, let's do G circle f using any technique. So this is g of f of x. So f of x, you know that is x squared minus 7. Now g of x is 2x. So the form of g is 2 times whatever you put. So 2 times, in this case, you are putting x squared minus 7. So you get 2x squared minus 14. So simply, you know what, let's do it the other technique. So this is method number what? I used method number 1, right? So the other way is using g. So g is 2x, so we have 2fx. But f is x squared minus 7. See, the same result. Basically, it's the same idea, just the writing order in the first step is different. And in order to get this more practice, let's keep doing more problems. And this composition of function idea is really helpful for our inverse functions. So you need to have a little bit practice for this. How about this? F of x equal x squared plus 1 and g of x equal x minus 3. How about this? I want you to find f of g of 2. First question. And part B, I want you to find g of g circle f negative 1. So first one actually f circle g2, but you can write it like f of g of 2. And how do you do this? Well, there are many ways of doing this. If you want, you can actually find for the first one. If you want, you can go ahead and find this, right? And then finally, once you get that function, the last function, you can simply substitute x equal 2 into your answer. You know what? Let's do that. So let's do that. It's a little bit lengthier way, but it's to get a practice. F, what is the form of f? It will square and add 1. So it will square g. X minus 3 is g. So f of g of x is x minus 3, and then x minus 3 will be squared because of the form of f and plus 1. So I get x squared minus 6x plus 9, and with this one I get 10. And when I apply to find f of g of 2, what I need to do, put x equal to in this one. So I get 2 squared minus 6 times 2 plus 10, which is 4 minus 12 plus 10. I'm getting 14 minus 12, which is 2. But this is the longer way. The easier way is actually, g of 2. First evaluate g of 2 right over here. And it's 2 minus 3, which is negative 1. Pretty easy. So g of 2, negative 1. So f of negative 1. Now use your f, evaluate negative 1. Of negative 1 is negative 1 squared plus 2, which is 1 plus 1, 2. See, the same answer. That one is much easier unless it's specified for you to find this one. Let's deal with this one. So g of f of negative 1. So g of f of negative 1. What you first need to do, find this guy, f of negative 1. So f of negative 1, you know what, let me find it over here. F of negative 1 is, no, you know what, let's write it in a proper way. We know f of negative 1 equals negative 1 squared plus 2, which is 2. So g of f of negative 1 is g of 2, which is 2 minus 3. The answer is negative 1, right? And I think you get the correct idea. You know what? Let's do one more. Let's make this interesting. The following are graphs of f and g. Now, without specifying what the functions are, actually you can write down the function by looking at the graphs. You know how to do that, but without doing that, let's say 1 2 3 4 1 2 3 4. I probably should use a different color for the next one. So 1 2 3 4 1 2 3 4, and joining 4 and 4, if I do a straight line like this is the graph of f, and the graph of g, and here -1, so going like that. So this point it's given 4, 3, and this point is 3, 2, this point is 2, 1, this is 1, 0, this is 0, -1. Similarly here, this point is 1, 3, this point is 2, 2, this point is 3, 1, and 4, 0, 0, 4. Those points. Okay. And if these things are given, I want you to find f of g of 4, first one, second one, f of g of 1, third one, g of f of 4, last one, g of f of 1. Can you pause the video and try it? Assuming that you have done it, first one, if I were you, what I would do, f of, first I would find g of 4. In order to find g of 4, I have to go to this graph. G of 4, I know right here this value, see 4 here, g of 4 is 3, so f of 3. Now f of 3 from here, I know that's 1, right? Now second one, g of 1, so again this graph, g of 1 right here, that function value is 0, so f of 0, so f of 0 right here, we got, that's 4. And next one, first f of 4, so I use this function, f of 4 right here, the function value is 0, so g of 0, 0, g value is -1, so the answer is -1. F of 1, so I go to this function, f of 1 up here, 3, so g of 3, for 3 I go here, and the function value is 2, so the answer is 2. And I think that's enough examples for composition of functions. And in my next video, we will be dealing with inverse functions. Thank you.